We are going to discuss about the thermal engineering in topic steam nozzle. Myself, I am Rajakumar, Assistant Professor, Department of Mechanical Engineering, Rohini College of Engineering and Technology. Course outcome: students can able to analyzing the performance of steam nozzle and calculate critical pressure ratio, highest coins level K4. Steam nozzle. A steam nozzle may be defined as a passage of varying cross section through which heat energy of steam is converted to kinetic energy. Steam nozzle major function is to produce steam jet with high velocity to drive steam turbine. These are the different types of nozzle. Before that, we should know the nozzle. What are the energy conversions is brought in these nozzles? First of all, the high pressure, high temperature steam first expand in nozzle embedded as a high velocity fluid stream. Then the high velocity steam coming out of the nozzle imbibing on the blade mounted on the wheels. The fluids steam suffer a loss of momentum while flowing past the blade, that is observed by the rotating wheel, ending the producing of torque. The moving blades move as a result of impulse of steam, that is causes by the change of momentum, and also as a result of expansion and acceleration of the steam relative to them. In other words, they also act as nozzle. A steam nozzle is a duct or passage of smoothly varying cross section area which converts heat energy of steam into kinetic energy. The shape of the nozzle is designed such that it will perform this conversion of energy with minimum losses. Actually, working principle of steam nozzle is during the first part of the nozzle, the steam increases its velocity, and then the later part of the nozzle in which of the steam derived more in volume than in velocity. So next we are going to see the types of nozzle. So first one is a convergent nozzle, second one divergent nozzle, third one convergent divergent nozzle. In which the first convergent nozzle, a typical convergent nozzle is the first figure shows the convergent nozzle. The cross section area decreases continuously from its entrance to exit. It is used in a case where the back pressure is equal to or greater than the critical pressure ratio. Then divergent nozzle, second one is a divergent nozzle. The cross section area of the divergent nozzle increases continuously from its entrance to exit. It is used in a case where the back pressure is less than the critical pressure ratio. The third one is convergent divergent nozzle. In this case, the cross section area first decreases from its entrance to the throat, then the increases from throat to exit. It is widely used in main type of steam turbines. Then flow through nozzle. A nozzle is a duct that increases the velocity of the flowing fluid at the expansion of pressure drop. Then a duct which increases the velocity of fluid and causes a corresponding increases in the pressure is a diffuser. Then application of steam nozzle. Steam and gas turbine and jet engine, rocket motor, it is used to measure the discharge of fluid. Example, venturimeter, injector for pumping feed pump to boiler, the supersonic gas turbine engine for the air intake when the air requirement of the engine is high, rocket, and for removing the air from the condenser using injector, spray painting, steam jet refrigeration. These are the application of steam nozzle. Then one example for problem: a convergent divergent adiabatic steam nozzle is supplied with a steam at 10 bar and 250 degrees centigrade. The discharge pressure is 1.2 bar. Assuming the nozzle efficiency is 100 and initial velocity of steam is 50 meter per second. Find the velocity. They were asking the final velocity. So first of all, taking the given data, first initial pressure P1 equal to 10 bar. Then temperature T1 equal to 250 degree. So exit pressure P2 equal to 1.24. Nozzle efficiency equal to 100%. Initial velocity equal to 50 meter per second. So if they given the initial temperature is 250 degree centigrade, mean maximum that the steam, the condition of steam is superheat steam, because after 120 or 130 it may be superheat steam. So to find the velocity of steam at exit, that is V2. So we have, first of all we are taking from steam table, saturation steam table, pressure P1 equal to 10 bar pressure, and 250 degrees centigrade. We can go through the superheat steam table. In the last session we are taking in the superheat steam table, and 10 bar and 250 degrees centigrade. So taking the value of H1 and S1 value. So from steam table for 1.2 bar pressure, from saturated steam table the values are taken of HF and HFG, S1, SFG. So these are the values are taken from the saturation steam table. In the first of all we are taking from superheat steam table. So in this flow is a isentropic flow. So S1 equal to S2. Then S1 equal to, we know the formula of wet steam. So SF2 plus X2 SFG2, because S1 value S2 value are same value. So the values are substituting this equation, we get the value of X2 value. So we know that the H2 value, that is HF2 plus X2 HFG. This is the wet steam for enthalpy of wet steam. Okay, we know the all the value, X2 value, HF2 value, HFG value. So from that we get the value of H2 value. So from we know the H1 value, H2 value, and they are given the V1 value. So from these the data we can find out the exit velocity V2. That is the formula for the V2 equal to square root of 2000 into H1 minus H2 plus V1 square. Some of the maybe some problems they are given negligible the initial velocity. So at that time we are not considering the V1 value. But this problem they are given the V1 value. So that we are putting V1 value in this equation. From this equation we got the value of the exit velocity, that is V2 value. Thank you.